take things through the heliosphere. Once they've reached the heliosphere, they propagate through into an environment that's been shaped by what came before. And we need to now learn not just to do that, as we can now do fairly well hydrodynamically, but we have to learn to do this effectively magnetohydrodynamically. And then, of course, we need to understand what happens in Earth space, particularly the geotail. What happens in these morphological changes to the Earth's magnetic field, the connection-driven changes in the Earth's magnetic field. And we have to go beyond the MHD approximation in many of these things. We have to create the ability for data assimilation techniques for the global magnetosphere. And we're thinking ahead on the solar side of getting polarization measurements of chromospheric and coronal vector magnetic fields, or at least line-of-sight magnetic fields in the corona. But we have yet to develop the capabilities to put those into a model for the global structure. So we better start working on that. Now, in terms of new instrumentation, the questions really are these. We're having a really tough time. It's probably impossible to just model the sun's magnetic field from the surface magnetic field up. So having a 3D information about the coronal field is essential. Binocular imaging of the solar corona could do that. Something like 5 to 10, 15 degrees of separation, so that we can work with it as with our brain on a computer screen to combine it to create the models of the state of the solar atmosphere before and after an eruption. We also need to better understand what happens in the Earth's magnetosphere, and interestingly, that's a tough problem. It's tough not just because it's a vast and dynamic space, but it's hard right now to agree on where to put those resources. So although we understand we need more resources, we really need to study where to put what kinds of resources, define the criteria. Somewhere in the inner part of the geotail where the field hesitates between open and closed, and does that dynamically. We probably would benefit greatly from an observatory that could observe the sun's vector field near the surface, at and near the surface, at very high resolution, a fraction of an arcsecond, and the overlying corona at matching resolutions. And the reason to ask for that is this. Often there are very small compact structures, well, compact looking at the sun from this great distance, that have left the sun in a coronal mass ejection that would not be readily observable in just a few arcsecond resolution. We need to work on the needs of ground-based instrumentation to complement magnetospheric measurements. We need to look at more of the solar surface, and that is something that will happen when, for example, the solar orbiter will come up. It will not do that continually, but it will be a great stepping stone by providing us polar field measurements and backside measurements, so that then we can define where our real needs lie. We have to have monitors to understand where particles come down from the evolving geomagnetic field, so that they can then be used, these particle impact sites, as tracers of what happens in the geomagnetic magnetospheric environment. Now my chair is standing up. There's a lot more to say. There is a second tier that has to do with what happens when we talk about radiation belt particle environments, storm-induced ionospheric disturbances. There, the bottom line of all this is there's a lot of geospace stuff, the blue text, that needs to be done. In addition to, of course, knowing what comes from the sun that I described in the previous tier. And here, much of the research will focus on knowing what the particles do, knowing that we can how to learn how to specify these particle environments, and eventually creating advanced new capabilities of having a denser sensor network in geospace looking at all these impacts. The last set of recommendations, and you can read all of these and we will have a final report, and please join us for the discussion in the session following up. The final set of recommendations has to do with this difficulty of forecast something before anything has happened, and that primarily has to do when we're looking at flares and solar energetic particles. Flares because they impact the way that the ionosphere and the high Earth atmosphere is going to respond. Solar energetic particles because they find their way within a matter of minutes into the geospace environment. For that, we would have to know whether a coronal mass ejection is in fact driving energetic particles. We have to learn how these energetic particles would make it through the heliosphere. All of that eventually to say we need also to think ahead of new in situ measurements of how energetic particles move through the heliosphere by looking at off-the-Sun Earth line. We do that now in part with instruments that are on the Stereo spacecraft or on some of the planetary missions. In the near future, we're looking forward to, for example, the Solar Orbiter that the European Space Agency is leading, and the Solar Pro Plus that NASA are working on as in situ sensors that are added to this overall complement. And of course, we have to work on an advanced development of ground and space-based ionospheric observation platforms to integrate all the available data into something that can then be readily distributed and disseminated to the users to correct their GPS and their GNSS navigation signals, and to understand radio propagation problems that might occur, for example, for the airline industry. Where would that leave us? Well, if I look at the skill sets that we now have to meet the needs on these various timescales along these various columns of impact pathways, there's really too much red. The only green there is the long-term galactic cosmic rays, because the incoming galactic cosmic rays aren't going to vary on a few-day timescale, except maybe if there's really some bad explosion nearby, but that's something beyond our skills anyway. But where we would like to be, and where we think we could come within just a matter of years upon working on this roadmap, is a much greener future. A state in which we think we can actually meet the needs of many of these sectors of society and many of our scientific interests once these recommendations are acted on, so that the green skills and the red needs have a much better matching from one to the other. I'm going to leave you with one last slide, which is basically the summary of these top-level recommendations. And the three most important things on here are, first, it says draft in big yellow letters underlined, because that's what it is. We need your input. Second, we need that input, for example, by talking to the team members, or by sending it to that particular email address, or by joining us for the discussion session that follows this. And as soon as I'm home, I'll put this particular presentation online at that website. Thank you for your attention.